Another important concept when doing drills here is for the checks. These checks can work on either attributes or the tuples. It is also a constraint actually. In other words, we can put a constraint on the value of some attributes by using the checks. So what is the check? Formally, we can represent the check as shown here, check for some conditions within the parentheses. It must be added to the declaration for the attributes. And the condition may use the name of the tuple, but any other relation or attribute names must be in a subquery. In other words, if we're checking some attributes, we can use it directly in the condition. However, if we are using some other attributes or relations, then we have to use subquery instead. And we'll provide you with an example. We can create tables for sales records. Inside we have both bar, beer, and price. Here we provide checks on both beer as well as price. So for beer we have a check, parentheses, beer should be in. We have another subquery as shown here, select them from beers. What does this mean? This beer attribute is this beer attribute, right? We can use it directly inside the check condition. We should make sure the beer should be in. I hope you still remember what is the in this operator, right? The beer should be in. We have a subquery. The subquery is to get all the names from the beers to this table, right? We will make sure this beer should exist in the beers table. Another check we have here is on the price. We check price is no greater than $5. I hope you can follow me right for this example. And the physical meaning for the price is very easy to understand. As for the physical meaning on the check for the beer, it makes sure the beer should exist inside the beers table, right? It provides a similar function as the foreign keys. We need to make sure the beer we are referring to from other tables should be a valid beer from the beers table, right? And then what's the difference of this check versus the foreign keys? They're very different, right? So the check we use for the beer, this attribute, is very similar to foreign keys. However, it is also very different from the foreign keys. The first difference lies in the kind of condition to enforce, right? I will still remember the foreign key need to ensure that the attribute we are referring to should exist in other tables. At the same time, this attribute should be the key, right, of the referred relation. Another difference lies in the time of this action of enforcing, right? So this foreign key allows us to do both update, delete, and insertion of new tuples to the tables, right? However, for this checks, we have some timing difference of the enforcing. So an attribute-based check is checked only when a value of that attribute is inserted or updated. We provide you with the example. When we insert some tuples into the sales table, we can check if the price is not greater than $5 or not for every new price and reject it if it is more than $5. In other words, we're enforcing these checks within inside this sales table we are defining here. As to check on the beers, we need to make sure beer is in the beers table. It's not checked if a beer is deleted from the beers table. It's very different for the foreign key, right? Foreign key will check both insertion, deletion, and updating. However, for the check, this constraint we use here, we ignore these deletions. So it's very different from the foreign keys, right? Okay, so this is about the check, this constraint. Check condition we showed before its own attributes. Actually, check also allows us to do some tuple-based checks. The grammar is very similar. We have check on some conditions, and we can use it to be added as another element of the schema definition or the table definition. And the condition can refer to any attribute of the relation. But any other attributes or other relations may require subquery. And checks can be used on this both insert and update only, and that will still ignore the deletions. And we provide you with the example, only Joe's bar can sell the beer for more than $5. Then we need to enforce this constraint in the table creation, right? When we create a table for sales, we have bar, beer, price. Then we need to have a check on this schema. We check bar equals to Joe's bar or price no greater than $5. Right? So this check condition we can add here. We need to make sure this check can be true all the time when we do the insert or the update of the records inside the sales table, right? We need to make sure the price should be always be no greater than $5, or it can be the Joe's bar, right? It is an exception we can make here for the Joe's bar. It can sell the beer for more than $5. Okay, so this is a type of based checks we can use in defined tables.